All right, so what about a problem like this? This is the kind of stuff we do in 7-1. It looks like stuff we've done in the past, and it's very, very similar. We're trying to find all the zeros of this polynomial. It's got 4 terms, and so the first thing you would correctly think is, okay, let's try grouping to see if we can factor it. It's not going to work. We'll just demonstrate that really quick. It's pretty easy to see. If I were going to try to group this, what's the greatest common factor from the first group, first 2 terms? It'd just be x squared, wouldn't it? Right? Because there's no number that goes into 6 and 35. So I'd get an x squared from the first group. What would be left over? If I divide each of those by x squared, 6x minus 35. Very good. Okay, from the second group, you can see right away that that's not going to work, right? If I assume that we have the same leftover, what might be the GCF that would go with that? What times 6x would be 48x? 8. So we could say, okay, well then try 8, see if it works. But when we try this out, when we see if everything distributes properly, it doesn't. X times 6x, yeah, that gives me my 6x cubed, check. That gives me my negative 35x squared. So far, so good. 8 times 6x even gives me 48x, but look at this. 8 times negative 35, is that negative 16? So it didn't work, right? So factoring by grouping is out the door. It's not going to work. So we got to do something different, and that's what 7-1 is about. Right, 7-1 is about what do we do if you can't factor by grouping? And all it is the rational root theorem. That's what this whole thing is about. So we don't know any zeros. We can't factor it. We've got to just try a bunch of candidates for zeros until we get one that works. Well, what's the list we're going to work from? So here's the way, let me just summarize the rational root theorem. It's in the text. I put the resources up for 7-1, so you can always go to the text and reference it if you want to, but you won't need to. I'll just tell you, here's what it is. If you've got a polynomial with integer coefficients, which is like every polynomial we've worked with, right? Then if you're going to get easy zeros, one that's not a square root, right? One that can be written as, with no square roots in it, then here's how it's going to work. The zero is going to look like some combination of, it's going to be formed from the factors of the constant and the factors of the leading coefficient. So here's the recipe. Those values of x would have to have in the numerator factors of the constant, right? So what are the factors of 16? Plus or minus, let's start at the smallest one. What's the smallest factor? 1. So plus or minus 1, then 2, then 4, good, then 8, then 16. Okay. On the bottom, we could have any of the factors in the denominator of 6. I won't even put the plus or minus there, though, because we already know that the fractions would be positive or negative. So that would just be a 1 or what else? 2, 3, or 6. So there's a ton of them, right? But we're going to start with the easy ones, and I promise you, these aren't going to be ridiculously hard problems. They're just, you're going to get a hit fairly quickly. So if we think of all the different, let's make a list, and we'll just go through the list from the smallest to the biggest possibilities and cancel them off as we go. So what would my list be? Well, let's start with the 1 on the bottom, right? Because that makes all of these integers, right? So we would just get 1, negative 1, 2, negative 2, 4, negative 4, 8, negative 8, 16, negative 16. And then from there we could move on and say, okay, what if we had a 2 on the bottom? How would that change things? Well, if I had a 2 on the bottom, I could get 1/2 minus 1/2. 2 over 2 is 2, that's already there. 4 over 2 is 1, that's already there. 4 over 2 is 2, that's already there. 8 over 2 is already there, and 16 over 2 is already there. Then I could move on to the 3's. I could have 1/3 minus 1/3, 2 over 3, right? If I'm using the 3 on the bottom, I'd get 2/3 minus 2/3, and that list would go on, but you're not gonna get there. I'm not gonna make these problems so you end up with these ridiculous fractions on the bottom. I'm not gonna do that. I mean, you could do it, it wouldn't be a horrible thing, but we're just not gonna worry about that, right? You're gonna get an answer somewhere from this list of the possibilities you get with a 1 on the bottom is gonna work, okay? So then we have to just try it, right, until we get a hit. Now, everybody understands how we got these numbers though, right? Right, factors of the constant divided by factors of the leading coefficient. And we're always gonna start with the integer, just factors of the constant divided by 1, right? So then it would just look like we'd make our little template. What are the coefficients? 6, negative 35, 48, and negative 16. And so when we put in numbers out here, this is where the remainder box would go, isn't it? Right? It's always going to be under the constant when we do synthetic division. Everybody agree? So let's go ahead and make a vertical line here. And so we know that whatever shows up in this column is going to be the remainder. And so if that's a 0, we got a hit, right? So let's try one. What's probably the easiest thing and the first thing we should try? Which one of those numbers up there? We just start at the right and work to the left. Start with the small ones. Let's try 1. See if 1 is a 0 of this polynomial. So I plug in 1. And then remember how we do this. So what we're really doing here is we're finding what the bottom row of synthetic division would look like. So we bring the 6 all the way down. Then how do I get the next number on the bottom? What do I do? When a number shows up in the bottom, you multiply and add, right? So 6 times 1 is 6 plus negative 35 is what? What's 6 plus negative 35? Negative 29. So 1 times negative 29 is negative 29 plus 48 is what? 19. So it's not going to work, is it? 1 didn't work. If I do 1 times 19, I get 19 plus negative 16. That's not a 0. So we'll cross 1 off. Didn't work. Move on to negative 1. So I bring the 6 down. Negative 1 times 6 is what? Negative 6 plus negative 35? Negative 41, right? Is that right? Yeah. So this isn't going to work, is it? Negative 1 times negative 41 is 41, plus 48 is huge, right? See what's going on? Everybody following this? So that's not going to work. We can already stop. It's not going to work. Let's try 2. Bring down the 6. 6 times 2 is 12, plus negative 35. Negative 23, good. 2 times negative 23. Negative 46. Negative 46 plus 48 would be 2. So that's not going to work either. So we just got to keep going down the list. And it might take you a little while to get one that works. Negative 2. I don't think that's going to work either, but we'll try it. Negative 12. We can try it. Negative 2 times 6 is what? Negative 12. Plus negative 35 is negative 47. That's not going to work. Negative 2 times negative 47 is a big positive number. Plus 48 is huge. Not going to work. Okay, try 3. Eventually we're going to get one that works. 3 times 6 is 18. Okay, so 18 plus negative 35 is negative 17, right? 3 times negative 17 is negative 51 plus 48 is negative 3. We're getting closer. 3 times negative 3 is negative 9 plus, that's not working, is it? Man, did I miss one here? Did I make a mistake on one of these? Is this one right? 6, 29. Oh, no. What about this one? 41. That's all right. Huh. It's not working yet. Let's try 4. Just see if 4 works. Six times 4, what's that? 24. So what's that going to give us? Negative 11. 4 times negative 11 is, oh, this is going to work. This one's going to work. This one's going to work, isn't it? So 4 times negative 11 is negative 44 plus 48 is 4. 4 times 4 is 16 plus negative 16 is 0, right? It took a while, but we got one that worked, right? So what does that mean then? Okay, so that means that one of our solutions is we want to find all the zeros. Well, there's a 0. 4 worked. 4 gave us back 0. But what is this telling us? That's telling us that what's left over when I divide x minus 4 into the polynomial is this smaller polynomial, right? So what is that? If I write that as a polynomial, what is that? 6x squared, right? Because this is the constant, the coefficient of x, and the coefficient of x squared. So 6x squared minus 11x plus 4, right? That's the other polynomial, or the other factor, right? If we were to factor this whole thing out, we would have gotten x minus 4, because x equals 4 was a 0, right? Times that, right? Times 6x squared minus 11x plus 4. We're trying to find the zeros of that. But we don't even have to write that stuff out. We just know that we want to set this equal to 0 and solve. How are we going to do that? It's a quadratic equation. We did a ton of this stuff back in Module 3. How do we solve a quadratic equation in standard form? Quadratic formula. I mean, we could try to factor it, but why? That'd be a really hard one to factor. Just put everything into the quadratic formula. And notice what happens here. If we solve this using the quadratic formula, what's a? It's in the form ax squared plus bx plus c equals 0. What's a? What do you know? A is 6. What's b? Negative 11. And c is positive 4. So those are really just going to be the coefficients that go into the quadratic formula, aren't they? Right? So if we do that, if we just solve using the quadratic formula, then x is negative b. So what's negative b if b is negative 11? 11 plus or minus the square root of, what's 11 squared? 121. Minus 4 times a times b, all divided by 2 times a. 2 times 6 is 12. So let's figure out then, what's this number going to be that's inside the radical? We want to figure out what that is. 4 times 6 is what? 24 times 4? 96. So we get 121 minus 96 is what? 25. So this whole thing in here is just going to turn into the square root of 25, which is what? 5. So this ends up, this is going to be easy. So we're going to get x equals 11 plus or minus 25, or sorry, 5, not 25. Over 12. So if we take the plus sign, what's that going to give us? 11 plus 5 is what? 16 over 12, right? So x equals 16 over 12, which reduces to what? 4 over 3. So there's another 0, right? What if we take the minus sign? 11 minus 5 is what? Is 6. 6 over 12 is what? 1/2. So there's my other solutions. So we got 4, 4/3, and 1/2. That's what I would enter in Moodle. So if this is my answer box, that's what I'd put in there. Okay? Make sense? I needed to find one 0 So what I was left with would be quadratic, and that's easy then. That's module 3 stuff, quadratic formula, right? Okay, go. I want to see one correct, one green check from 7-1, and then you're free to do whatever you want to work on.